Welcome to my YouTube channel, The Proton Family. Today we'll be discussing some tricks to calculate the number of moles, molecules and atoms. Let's begin with this. This topic comes under the chapter Mole Concept. The trick number 1 is to calculate the number of moles. The number of moles are denoted by N. The formula comes out to be given weight, and this given weight will be the weight that will be given to you in the question. The molecular mass that you already know, or it can be given in the question also, but you should know this. The first question that comes is calculate the number of moles in 22 gram of carbon dioxide. The first thing that you have to do in this question is to calculate the molecular mass of carbon dioxide. The molecular mass of carbon is 12 plus there are 2 oxygen atoms, so 2 into the molecular mass of 1 oxygen atom, that is 16. This comes out to be 44 grams. The molecular mass of carbon dioxide is 44 grams as we have already calculated here. Then we'll calculate the number of moles by the formula which we derived before, that is the given weight upon the molecular weight. I have denoted given weight by GW and molecular weight by MM, that is the molecular mass. We have to use this formula, therefore I have written formula used. So the given weight was 22 grams. The molecular mass that you calculated is 44. Then by cancellation it comes out to be 0.5. Therefore the number of moles in 22 gram of carbon dioxide comes out to be 0.5. We further proceed now to trick number 2. The trick number 2 is to calculate the number of molecules. The number of molecules are denoted by capital M. Molecules is equal to moles into Na. Now you will be wondering what this Na is. This is the Avogadro's number whose value is 6.22 into 10 raised to the power 23. You have to remember this value. Calculate the number of moles in 18 gram of H2O. The question may come like this. The first step that you have to do in this question is to calculate the number of moles, because the formula was, what is the formula? Number of molecules is equal to moles into Avogadro's number. So obviously you need the number of moles of 18 gram of water. So we'll calculate the number of moles. So before calculating the mole, the first priority goes to the molecular mass of water. Similarly, calculating the molecular mass of water, as you calculated the molecular mass of carbon dioxide in the previous question, we get 18 grams of water. The moles will be 18 by 18 as the given weight was 18. This 18 is the given weight and this 18 is the molecular mass that you calculated here. It comes out to be 1. So we have 1 mole of water. The second step that is asked in the question is the number of molecules. The formula used is number of molecules is equal to moles into the Avogadro's number. Moles calculated 1 into the Avogadro's number whose value is 6.022 into 10 raised to power 23, which comes out to be 6.022 into 10 raised to the power 23. Now we further proceed to trick number 3, that is to calculate the number of atoms. The formula is atoms is equal to molecules into atomicity. First of all, you need to know what atomicity is. Atomicity is number of times an atom occurs in a molecule. This is a very easy concept. I'll be telling you with the help of an example. I have taken the molecule 2B H2SO4, that is sulfuric acid. Atomicity of hydrogen in this is 2. What was the definition again? It was number of times an atom occurs in a molecule. Atom is asked, that is hydrogen here. The molecule given to you was H2SO4. The number of time hydrogen occurring in the molecule is twice because it is H2. This is the atomicity of hydrogen. Next comes is sulfur. The sulfur in H2SO4 is 1 because like no number is written, so we consider it as 1. And the oxygen similarly is H2SO4 4 is the atomicity of oxygen. So this was the concept of atomicity. Now comes the question on atoms. Calculate the number of atoms in sulfur and oxygen in 128 grams of SO2. So first of all, number of atoms of sulfur and oxygen. First off, you have to calculate the number of moles. Molecular mass of sulfur dioxide. Priority is given to molecular mass because without molecular mass you will not be able to calculate the moles. Similarly, as we calculated the molecular mass of water and carbon dioxide in the previous problems, we will do same here. Sulfur mass is 32, twice oxygen 2 into 16, we got 64. Moles 128 given weight upon 64 the molecular mass, we get 2 moles. Second of all, we'll calculate the molecules. Molecules formula is molecules is equal to moles into the Avogadro's number. We are making it easy. We did not use the value of Avogadro's number. We just simply wrote Na, the denotion of Avogadro's number. Now the third step comes. What is asked? That is the number of atoms. Atoms of sulfur will be twice of Avogadro's number, that is the number of molecules, and 1, that was the atomicity of sulfur in the SO2 formula. So 1, this is the atomicity. The second, atoms of oxygen, twice into the Avogadro's number, these are the molecules. 2 is the atomicity, that is here. I hope this question is clear. So the atoms of oxygen comes out to be 4 into Avogadro's number. So now when we are done with 3 of our tricks of calculating the number of moles, the number of molecules and the number of atoms, this comes out to be the conclusion. This small flow chart is very important that you should keep in your mind, and it is very easy. It only includes the 3 formulas that you did in the previous 3 tricks I taught you. The 2 formulas written additional in yellow boxes are the formulas that are derived from the formulas we learnt previously. So notice this, that the second formula of calculating the number of moles is molecules upon the Avogadro's number, that comes from this formula. And to calculate the number of molecules, the second formula, that is molecules is equal to atoms upon atomicity, comes from this formula. So you can calculate 3 quantities, that is moles, molecules and atoms, only by just 3 formulas that are very easy to learn. That is, moles is equal to given weight upon molecular mass, molecules is equal to moles into Avogadro's number, and atoms are equal to molecules into atomicity. I hope I made calculating moles, molecules and atoms easier for you, and you will be enjoying doing the questions on this concept. Thank you.